Hello and welcome back to Keon's Lab, and look what I've got. It's a FLIR or FLIR, I don't know how you pronounce it, thermal camera. This is the FLIR 1 Gen 3, and I didn't get this just to play around with it. As cool as the thermal camera is, I'm actually working on a little secret project slash product that I'm going to be revealing kind of soon, that's going to really benefit from having a thermal camera to develop the algorithm for its system that's going to be controlling it. Enough about that, let me just get into the thermal camera itself. We will be unboxing and showing the first tests of the FLIR 1 Gen 3 thermal camera for iOS. And this is their non-pro model, so it does not support Thermal Studio, which is a subscription software offered by Teledyne FLIR, which is the name of the company that produces this product, and a wide range of other civilian and military products. The FLIR 1 Gen 3 thermal camera features a thermal resolution of 80 by 60 pixels, giving a total of 4,800 pixels. And these are not like a traditional camera where it's capturing light. It is actually reading the temperature of the surface and generating an image by colorizing the numbers. It also features an adjustable connector for phone cases, I'm assuming. We're gonna see what that's for. And the temperature range on this thing is anywhere from -20 degrees Celsius to 120 degrees Celsius. In Fahrenheit, that is -4 degrees Fahrenheit to 248 degrees Fahrenheit. And the reason I actually picked the original FLIR thermal camera and not a knockoff one is for two reasons. One, because it is a thermal camera and I want to be able to trust the numbers that they're putting on here. I might as well go with like the established brand. But the second one is their MSX technology, which apparently is supposed to give a lot better resolution to your thermal imaging compared to a standard thermal image sensor or thermal camera. And it also does come with a free thermometer, but that's not really the point of this video. The point is the FLIR camera. And I'm going to be doing tons of cool stuff with this because this is one of 3 things that I'm going to be getting to really start bringing this channel to life. The first one is obviously the thermal camera. The second one is a dual output 10 amp DC programmable power supply, because the last one I got from Amazon, kind of disappointing in terms of the quality of the connectors and the potentiometers. But one example of what I want to be doing with this is comparing cheap thermal compounds versus something like an Arctic Silver thermal compound that costs like $12 each. Now, I'm not sure if this is a counterfeit or a real one. Like, the stuff back here kind of gives me the sense that this might be like a counterfeit, but whatever it is, it definitely has a higher thermal conductivity because just by holding it, I can definitely tell the difference versus this one. Yeah, there's a pretty big difference. And just by zooming in on here, you can see the advertised thermal conductivity is 1.93 watts per meter Kelvin, which is absolute garbage. And this, let's see if it says. Apparently, I've searched online, apparently it's about 8 watts, 8.5 watts per meter Kelvin. Or it might have just been 8, I'm not sure. And just for comparison, copper has a thermal conductivity of 398 watts per meter Kelvin, which makes it a very, very good thermal sink material. However, it is a bit expensive as a metal. Aluminum has a thermal conductivity of 237 watts per meter Kelvin. Silver has a thermal conductivity of 429 watts per meter Kelvin. But graphite, on the other hand, has a thermal conductivity of up to 2,000 watts per meter Kelvin. That is insane. And really explains why Formula One cars use graphite composite brake pads because that is an insane amount of thermal conductivity. 2000 watts per meter Kelvin compared to 398 for copper. That is crazy. And that's why graphene is going to be such a cool material once it's mass producible at a cheap scale, because you can get the same or even higher thermal conductivities using a single atom thick sheet. So like imagine rolling up a sheet of graphene and using it like a thermal wire, where you break it up into individual little slits on each side. That's just one of the things that I'm working on, and which is why I'm going to be needing this. So let's get to unboxing the FLIR 1 Gen 3 thermal camera. I'm going to use this X-Acto knife for cutting any seals. And if you have an X-Acto knife, I do recommend putting like tape here to prevent the lid from just slipping off, because I do find the lid is way too loose, which is kind of unsafe. So how does this... Okay. Kind of looks like a phone box. Are they a Swedish company? And fun fact for why their company name is Teledyne FLIR and not just FLIR Systems is because they were acquired by Teledyne Technologies in 2021. And I actually really like that name, Teledyne. It sort of has like a old school yet modern thing to it. It sounds like a type of company that I'd want to run someday. Made in Estonia. That's pretty cool. I've never seen that before. So there's a product marker marking it as iOS, and a little arrow marker, and I'm assuming this is meant to slide out. My hands are really sweaty, as you can see, because I have 400 watts equivalent worth of lighting less than a foot above me right now. Wow, that was a nice package. So I am not sure whether the seal needs cutting. Yeah, it does, because this is going to open like a book. So, or I'm assuming it is, because it's glued here, but not here. Never cut towards yourself. I need to change the blade on that. Oh yeah, it was like a book, as I said. Let me focus. So, FLIR 1 Gen 3 iOS unboxing. Now that's what I call attention to detail when it comes to a box design. So you can see there are two magnets here, and that is the more expensive type of packaging, ones that have inlaid magnets. And actually, before I take it apart, I do think that is a pretty good slogan for their product, because if you're working with like thermal stuff and you don't have a thermal camera, you're basically working blind. So it really is like a pretty good slogan. So that is the device itself. It's not that big. I wonder what's inside of here. And I'm doing it off camera just in case there's like warranty codes or whatever. So this one is just a thank you thing. And this is another aspect. So putting a face to a brand, in my opinion, is a very, very valuable thing to do. It's something that I aspire to do once I have my company running. Let's see what else is in here. It's a getting started booklet, or yeah. So let me just make sure my hands are dry, and we can take this out of here. And it apparently comes with a case and charging cable. So here's the device itself. It has, is this like a retractable or extendable connector for cases? Actually, let's read through that booklet. I'm inclined to believe that this is, yeah, as a slot move. Look at that. Pretty neat. I think I'm just gonna keep it at around what it came at, like that. And the two cameras, one seems to have like a thicker filter on it or something. Seems like an IR filter. I'm really not. I've actually just started reading a textbook on infrared thermal imaging. I can't say with certainty if that is what it is. I also like the little blue painted aluminum, and it has USB-C charging, which is quite neat. What looks like an LED, power button, because it does have a battery on the inside. We have the, what I'm assuming is the case, and I actually haven't watched a video on what's inside of here. I'm just saying that because it had a picture of a case on the box and a wire, and I see they've adopted the X to denote connection, or that it comes in the same box. But let's take the case out, and hopefully it doesn't have a bad quality zipper on it like a lot of free cases do. I don't think it will, because it does seem like a pretty, yeah, it does seem like a pretty good zipper. Oh, that's really cute. That's adorable. Look at that. This reminds me of that, of my, I had like a 3DS case when I was small. Never really played the DS when I was small, or any game console really, but it's like a mini version of that. So I don't know how this is supposed to go in. If it was me, I would just put it inside like that, because, you know, actually, that might be how it's meant to go in. Because, like, I'm assuming here is where you would put your charging cable, and let's see how. So it's quite rugged, but I personally am not a fan of slipping stuff underneath there so that it's able to be impacted like that. I would actually just put it on there and not even put the cable in if it was me. Let's see if it would shake. Yeah, so it seems pretty stable, and if anything, it does shake around a little bit. So let's put that down. And the final thing in the box that we're gonna take out is the USB-C charging cable, and that is a pretty big cable and looks pretty high quality too. This should have enough charge because I haven't charged it yet and it's straight out of the box. And for those of you who are not aware, any devices containing lithium-ion batteries, like iPhones, like really like literally anything, will ship not fully charged, but at anywhere from 40 to 60% at most. And that's because when you're storing lithium batteries, storing it at around half charge is the best way to keep them from degrading over time during storage. Because I am using my iPhone to record this video you're watching, I'm going to have to switch over to my old Samsung phone for recording the part where I inserted and set it up, and then we're going to switch over to the thermal camera view. So after letting it charge for only maybe 5-10 minutes, it seems to be full, so maybe I was a little bit underestimating on how much they kept the battery discharged, but just going in the App Store and searching for FLIR, you see the two apps, and it's FLIR 1, I think, that you want. And it's going to start installing. So opening the app, FLIR 1, then I'm just going to skip past this part. Then select the device. Oh, and it's Bluetooth. Okay. Well, I need to turn it on. So it said press once. So, Yes, I said yes. Allow new connection. Does it want me to? Yeah, okay. And push. Push the button. Yeah, I think it's low power. So we're gonna charge it. So I was right. They don't charge it to a significant amount before shipping. So I'm gonna charge it and come back once it's charged. Okay, so it has been approximately 40 or 45 minutes that I've been charging this, and it seems obvious that the battery was low because it did get quite warm when I was charging it. It does suggest using a 1 amp power supply to charge it. Now I'm not sure whether it has a built-in regulator or not. I would hope that it does, so I'm not sure if it matters what type of USB port it's plugged into. But in general, if you want to keep the heat low when charging, and therefore the buildup of internal resistance low in your battery, it's better to charge it as low of a current as you can. So using the 1 amp current port on your USB charging device. So let's see if this works. So I have the app open, and it says to press, and I'm going to mount it that way. So press the button once, and it says when it flashes green to plug it in. Now, it only flashed green when I was charging it, and you're not supposed to use it while charging it. Hear the clicking? Okay, it's flashing green now. So it was a charging, just didn't have enough power in it. And nice. So let's see. Okay, so I'm going to do two really cool tests using this thermal camera. And after doing some experimentation, I do kind of actually like the strap here. I just have to be careful not to exert any force onto the connector when putting it in. So I'm going to do two really cool tests to show the camera in action, and that are going to look really cool under the camera. So I'm going to do one demonstration for hot and then one demonstration for cold, so you can see what it looks like. And the first one is going to be the activation of a hand warmer. Now these are typically used for skiing, and somewhere on the back here, yeah, it's advertised as having an average temperature of 135 Fahrenheit or 57 Celsius. Keeping in mind that it does take 15 to 30 minutes for it to really get to that temperature. So I'm going to switch over to the thermal camera now, and let's activate this hand warmer. So with the lights now turned off to reduce interference, we have our hand warmers here. My hands are 34 degrees Celsius, and the tiles are 23.4 degrees, so 23 degrees Celsius, right about room temperature. So let's open one of them up and see in real time as it starts heating up. It's just calibrating right there. Oh, I can see it turning green already. I'm gonna hold it from the edges so my hands don't warm it up. Let's give it a quick shake. Now hold. Oh my god, this is so cool. Shake it. The frame rate might be a little bit low on here, because it's doing a thermal. Wow, look at that. I'm gonna put it on the box and then put my hands like here. Wow. Let me shake it a little bit more. Oh, not the box. Yeah. And I actually find it helps to mix in because the stuff inside of here is just like iron powder and some filler material, salt, and a little bit of moisture. And wow, it's really glowing now. 36 degrees. $37, $38. Let's put it all in one corner and fold it over like that. Mix it up. Get it nice and incorporated. Get some oxygen in there. Wow, we're at 40 degrees now. 41, 42. So this is quite neat. And the second demonstration I will be doing using the thermal camera is to show you what it looks like when the stuff inside of a cold pack is added to water. So this is calcium ammonium nitrate, and it's the stuff that they used to use in cold packs, the instant cold packs that you would normally find in first aid kits. And I remember the package advertising that it could get as low as minus 17 degrees Celsius. And this should be able to go below the normal freezing point of water without freezing, because the ammonium nitrate has a similar effect on the freezing point of water as salt does. And very quickly, the reason why it makes the water cold is because when ammonium nitrate is mixed with water, it splits the water molecules, something called dissociation, where the solid, desiccated ammonium nitrate, which is made up of ammonium and nitrate polyatomic ions, become aqueous polyatomic ions. And the amount of ammonium nitrate I have here is probably way too much for this amount of water, but I wanted to get it really cold. So without wasting any more time, let's switch over to the thermal camera view. And it should look pretty cool because it's gonna look like lava spinning around in here, except like blue instead of red. So notice how when my hands are in the frame, it switches its contrast because it's all relative. And normally I would have to keep my hands in the frame to keep it from switching back, but I can just put this hand warmer here and it'll keep it. So time to add the calcium ammonium nitrate to our water. Our water appears to be at around 23 degrees, and the calcium ammonium nitrate doesn't really matter. I'm going to put it on a piece of folded paper to prevent the cold from going into the tiles, or more like the heat from being extracted from the tiles. Without wasting any more time, let's add the calcium ammonium nitrate to the water and see how the temperature drops. Just move this center of the frame, and 3, 2, 1. Just mix, 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 mix. So the temperature is not dropping right away because it takes a little bit of time for it to not only cool down the beaker, but cool down the liquid as well. And the reason this is more suited for being a cold pack is once I show it against my hand, it can take a thermal load and not really increase in temperature that much until it is exhausted. So as I'm mixing it, the temperature is dropping. So we've dropped almost 3 degrees now. And it's probably even lower than what it's showing, because when it comes to detecting cold, the interference from even my fingers is going to throw off the measurements by a little bit. But now it's starting to dissolve. The temperature hovers around 20 degrees because there isn't enough water. And it doesn't really help that it's a glass beaker. We're going down to 19. The reading also appears higher than it should be because it's measuring the top of the water rather than the bottom where all of the ammonium nitrate has sunk and is now dissolving. Now watch what happens when I put it on my hand. It consumes the thermal energy from my hand in order to supply the energy required to split the water molecules, resulting in a cold spot on my hand, which can be clearly seen on the thermal camera. Let me spin it. And yeah, that's pretty cold. I'll watch. Leaves cold spots on my hand, and it looks so cool. Look at that. Notice how the spots decrease in contrast as the thermal resistance of the glass between my arm and the still cold solution goes up. Letting the glass cool down for a few seconds lowers the thermal resistance between my arm and the cold solution. Let's see what the temperature is. Still at, oh, it's 19. It's still maintaining it. It's actually gone down a little bit. Look how blue that is. My fingers don't even make a difference. Just taking all of that heat in. Because that ammonium nitrate really wants to dissolve in the water. You might not be able to see it, but I've added way too much ammonium nitrate in here. But all the undissolved nitrate is sunk to the bottom because it's gotten too cold for it to dissolve. But it really, really wants to dissolve. So as long as it's not saturated and there is heat present, it's going to suck that heat and use it to dissolve into the water. So I'm just spinning it. And now it's starting to go back up in temperature because it's all dissolved. And yeah. And the hot pack, the hand warmer, if anyone didn't know, if you've activated it but you don't want to use it anymore and it's still like got a lot left in it, you can just seal it in a plastic bag, or preferably 2 or even 3 plastic bags, like double, triple bag it. And by blocking the oxygen, it'll actually cool down, and then afterwards, like even months later, you can open it back up and reactivate it. And as long as it was an airtight seal, this should last for quite a long time. So you can see I put it in a single Ziploc bag and it's down to 27 degrees. But if I open it back up, watch what happens. Start mixing it up. And it's up to 34 degrees already. Shift. You can actually see the material on the inside. So if I go like this, see? All the hot material is on the bottom now. And if I turn it, you can see it spills like sand. It's pretty neat. 37 degrees, but I don't really need a warmer right now, so I'm gonna put it into the bag again. And then it's gonna consume any oxygen in the bag And if it's an airtight bag, then it's going to stop the reaction. And the reaction, by the way, is just the tiny amount of moisture and salt that's already in here. Like, that's how it ships. And the iron powder reacting with the oxygen that's diffusing through this, well, you can't see it, but through the canvas material. And the oxidation is what creates the heat. And our calcium ammonium nitrate is 23 degrees, so it's back up to about room temperature. So that is it for this video. Please remember to like and subscribe if you enjoyed this unboxing / review, and I will see you in the next video.